Okay, so here we go, session number 4. Oops, I meant to delete that, but that's okay. You saw it. You got a sneak peek. 2x squared plus 3. I was going to try to erase that, but that's okay. Basically, here's what I want you guys to do. We're going to do something. We're going to step it up a notch. Okay. That's a quadratic equation. Let me just kind of put this out in front. F of x equals 2x squared. I mean, you guys can certainly see that, this equation right here generates this table. If I put a 1 in there, 1 squared is 1, 1 times 2 is 2, 2 plus 3 is 5. If I put a 2 in there in place of that x, 2 squared is 4, and 4 times 2 is 8, and 8 plus 3 is 11. If I put a 3 in there, 3 squared is 9, 9 times 2 is 18, plus 3 is 21, and so on and so forth. This is your input list. This is your output list. Now, I always wanted you guys to kind of back this up to 0, but really what I want you to do is I want you to specifically look at the difference columns, okay? And you're going to notice that you're not going to get the same number in the first difference column because it's not linear. I just showed you the equation. That's not a linear equation. That's a quadratic equation because it has this little squared there, x squared. Now let's run our little difference trick. 11 minus 5 is 6. 21 take away 11 is 10. 35 take away 21 is 14. And so on and so forth, okay? It just keeps going. Now, because it's not the same number every time, this is not linear. So we got to go to the second difference column and see what's going on here. 10 minus 6 is 4. 14 minus 10 is 4. Well, if we kept going with this pattern, you would see that these are just going to repeat themselves, the 4s. Okay? Now, what's half of 4? Do you guys remember? Because this is kind of the trick. Half of 4 is 2. So A equals 2. And remember, up there to your left on the glass, I wrote it down, f of x, f of x equals ax squared plus bx plus c. Well, A is right there. It's always half of whatever this number is that keeps coming up consistently. So we can actually put a 2 in place of that A, 2x squared. Now, remember I told you earlier, if you just keep backing this thing up, okay, we know 11 minus 5 is 6, and then the next one up here would be, what, 2, I think, because this is going up by 4s every time. 5 minus what is 2? 5 minus 3 is 2. Now, that is your y-intercept right there. Now, look at your equation, 3. That's your c value right there. That's your c. And in this case, b is 0. There is no bx. See, we don't have anything in the middle. We just have an a and a c value. So b is practically nothing. So I just kind of want you guys to kind of see that this is your input, this is your output. But more specifically, I want you guys to understand how to graph these things. So if I'm going to make a quick sketch of this, sorry, it's kind of hard. Let me just go like this. Okay, x, y. Okay. Now let's just make a quick sketch of this graph here. If I go to 0, 3, that's my y-intercept, over 0, up 3. Well, let's just say it's down here, 1, 2, 3. I'll make it kind of a small scale, 1, 2, 3, 0, 3. The next one's over 1, up 5. We'll say 5's right there. Over 2, up 11. Well, as you can see, what's happening here, this thing's starting to curve upward. Okay, 3 is 21. Well, 21 is going to be like way up here and so on and so forth. Now, we don't have a left side of this graph. So we kind of need to put some negatives in here to be quite honest with you, so we can see what happens over on the other side. Well, if I put a negative 1 in for that x, this is just 2 times negative 1 squared plus 3. Negative 1 squared is negative 1 times itself. Negative 1 times negative 1 is a positive 1. That's a positive 1 times 2 plus 3. Well, 2 times 1 is just 2, and 2 plus 3 is 5. So look what is happening here. Up here we put in a positive 1, got a positive 5. Down here we put in a negative 1, and it's also a positive 5. So if I graph this, I'm going to go to the left 1 and up 5. So look at that. Now it's just mirroring every single one of these points. So basically, we're going to get the same exact numbers. So if I put in a -2 and I run all the math, if I put a -2 in there, I should get an 11. And we can double check that. So -2, 11. So you're just plugging in numbers into this x and generating all these outputs so that you can graph these. I'm going to give you guys a little practice to start graphing these next. All right. And I guess it's raining cats and dogs in Orlando. Or it's going to be while I'm there. So anyway, I don't think the weather's going to be great. Not to mention, I'm not going to even be outside to enjoy the Florida weather. So anyway, talk to you guys soon.